Good morning, students. So we are started with the stochastic process. So let me continue some examples also last time we have given of stochastic process. So now let us start with the discrete time Markov chain. I think my screen is now visible to you. Okay, so now we are starting with the discrete time Markov chain. DTMC. So as the name suggests, the discrete parameter, discrete time and discrete parameter, and chain means discrete state. Okay, so this is discrete state space and discrete parameter or time stochastic process. So this discrete time Markov chain, this is stochastic process xn, n is 0, 1, 2, and so on. It takes that takes on a finite or countable number of possible values. That means the state space is basically finite or countable. So xn is said to be a discrete time Markov chain. If probability that x n plus 1 is equal to j, given x naught is equal to I naught, x1 is equal to I1, so on to x n is equal to I, is same as that of probability x n plus 1 is equal to j, given xn is equal to I, where these I, j, I naught, I1 and so on, these belongs to the state space. Okay, so state space is basically all these values. So for example, the state space may be taken as 0, 1, 2, 3, and so on, and these I naught, I1 and so on are these particular values of those. Okay, then xn is said to be discrete time Markov chain if this happens. That means the future xn plus 1 is equal to j, j is the state, and this is the step x and n plus 1 step, the state is j, and this is the initial, at the initial time it is in state I naught, at first step it is in state I1, and at nth step it is in state I. Then the future depends on the present, not on the past. Okay, then the Markov, the stochastic process xn is said to be discrete time Markov chain. Okay, so this is basically can be denoted as P initial state I, final state j in one step, and n is also depends on n. This is the transition probability. And this, if this transition probability also becomes independent of this n also, then this is known as the stationary transition probability. Stationary transition probability. So we can denote this as Pij, and the corresponding for corresponding stationary transition probability, corresponding Markov chain is known as the homogeneous Markov chain. Now, in the same fashion, you can just write down that because it has stationary transition probability, so therefore we can write down that this value is same as that of probability x m plus 1 is equal to j given x m is equal to I. This is same as that of probability x1 is equal to j given x naught is equal to I, because it is a stationary transition probability. So from now on, we will assume that if a discrete time Markov chain is given, then that is basically corresponding transition probability, stationary transition probability, and corresponding Markov chain is basically homogeneous Markov chain, otherwise it is specified. So now let us say that this state space contains the elements 0, 1, 2, and so on. Now, what is the stationary transition probability? This is P transition probability x n plus 1 is equal to j given xn is equal to I. That means this is I is the initial state and j is the final state, and these n is basically step. Okay, so by varying I and j over the, because these are the probabilities, so therefore clearly this Pij should be between 0 to 1 for all I, for all j, and let us say that we, for fix I, if I sum this Pij over j over all possible values of j, so then what we will get? Anyone? I am summing this conditional probability over j values for fixed I.
Pxi.
That will be 1 because I know that sum of the probability should be 1. Na? For fixed I, summing over all the possible values of j. By the definition of conditional probability, this will be 1. Summing over all, that means for fixed I, if I make, let us say, I make here and j I make here. Okay, so I is basically 0, 1, 2, and so on, 0, 1, 2, and so on. So we can make a transition probability here. We can make a matrix here, which is P0, 0, P initial is 0, final is 1.
Excuse me, sir.
Yes.
So could you please once again explain what does xn and xn plus 1 represent here?
Okay. So xn is equal to I means that the process is in state I at time or step or transition n. So n is a step, I is the state.
Okay, sir.
So here initial state is 0, final state is 2, and so on. And here this will be P10, P11, P12. In the same fashion, this will be initial is 2, final is 0. So P20, P21, P22. And from this relation, we can see that sum of this, if I sum these, this will be 1. Similarly, because we are fixing the initial I, fixing the I, okay, 0. Similarly, sum of P10 plus P11 plus P12 plus so on, this summation is also 1. Okay, so in this fashion, we can easily see that using the definition of the conditional probabilities that this summation is 1 here. So this is known as the transition probability matrix. So we can denote this as P or P1. Okay, so this is known as
So
the
what is that suffix one? No, that one written on the top there.
uh,
Power. Why one? What does it denote?
one denoting that only this is there. That means in one n is there, n is there, and one in one step we are moving from I to j. For example, if some particle is there, here is a particle. So let us say in this particle is moving from, let us say state is, let us say this is I, this is state j, this is some other state L. So this is moving to this here in one step. Okay, so this x, it may be that xn is equal to I in nth step, it is in I, but in x in one step it will move to j. In this fashion, you can understand something like this. Is it okay? This is
Yes, sir.
one step it is moving. Okay, so that is basically that one it is denoting. So this is basically transition probability matrix TPM, transition probability matrix. Okay, so sum in a row. For example, if I take this row, P00 plus P01 plus P02 plus so on, this will be 1 because of this. Similarly, the second one also P10 plus P11 plus P12, that is also 1. Okay, so this is the here thing. Okay, so let us, so this Pij is also can be denoted as Pij1 also, because in the same fashion, in one step it is moving. So you can denote this as Pij1 also. Okay, so let us take an example. Consider a game of ladder climbing. There are 5 levels in the game. Level 1 is lowest bottom and level 5 is the highest top. a player starts at the bottom each time a fair coin is tossed. If it turns up heads, the player moves up one rung. If tails, the player moves down to the very bottom. Once at the top level, the player moves to the very bottom. If tails turns up and stays at the top, if head turns up, let xn be the level of the game in the nth step or transition. Find the TPM and the state space. So clearly because there are 5 levels, level 1, level 2, level 3, level 4, level 5. So xn be the level of the game. So state space, the value taken by xn. So that will be 1, 2, 3, 4, 5. So this is the state space. Now, what we want to find the TPM. Okay. Because it is clear that level is 1, 2, 3, 4, 5. So a player start at the bottom. Each time a fair coin is tossed, it turns up head. The player moves one rung. If tails, player down, move to the bottom. Okay, so this is the game basically. So here, first of all, player moves 1 with probability P and it remains down Q. Then from 2 to 3 with probability P. P is the probability of success. That means probability of getting head. Okay, then okay, so this is basically Q. Basically, it will move 1 to 2. It will move, or with probability P and okay. So player moves up one rung. Okay, so with probability P, it will from 2 to 3 it will move. Otherwise, tail comes, it will move to the very bottom. Similarly, from 3 to 4, it will move with probability P. Otherwise, it will move to the very bottom with probability Q. 4 to 5, it will move in the one, and otherwise it will move to the very bottom. Okay. Similarly, in the last, it will move from 5 to 5, it will remain there. Otherwise, if tail comes, it will move to the down, to the level 1 with probability Q. And P and Q, because it is a fair coin, P and Q is basically half here. So now it is clear that Xn is a Markov, discrete time Markov chain, because the future, it depends on basically the, because you know that Xn plus 1 is equal to J, Xn is equal to I, Xn minus 1 is equal to I, and minus 1, and so on. So what is the level? Okay, so that doesn't depend on the previous one here, because if it is at 2, so it doesn't matter from, for example, if it is in the present at 2, it doesn't matter from where it has come to 2, but only it depends on how it is there. It depends on the next step only, not from where it has reached there. So therefore, Xn is a discrete time Markov chain here. And what is the TPM? TPM is P initially 0, 1, 2, 3, 4, 5. Finally 0, 1, 2, 3, 4, 5. This is the, okay. So P00 from state, sorry, this is start from 1 basically. So because states are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So P11. That means it is, if it is in state 1, it will remain in state 1 with probability Q. But Q is half. Then if it is in 1, it will move to 2 with probability half. That is P. And sum in a row is 1. So therefore there will be 0. From 2 to 1. 2 to 1, it will move with probability Q, half. From 2 to 2, it cannot remain there. From 2 to 3, it will move with probability P, half. 0, 0. Similarly, other also. Half, 0, 0, half, 0. Then half, 0, 0, 0, half. In the last, at the level 5, it will either remain at 5 with probability half, with probability P, or it will move to down 0, 0, 0. So this is the TPM here.
So could you explain how the sum of the probabilities for a given row is 1 again? I didn't understand that.
Okay.
Because in this particular example, if we see the probability from 1 to 3, intuitively we can think of it as 1/2 probability of moving up to 2. And then
No.
again it has
It is
1/2 probability.
talking about only 1, because Pij is a probability that xn plus 1 is equal to j given xn is equal to I. So in one step it is talking about. In what you are talking about in 2 steps or 3 steps. Okay.
Right,
So
right.
that is,
Yeah, got it.
so other thing is how the sum in a row is 1, because you know that probability that if I sum xn is equal to j over xn plus 1 is equal to j given xn is equal to, let us say, 0. So this is some probability. Also, by the definition of the probability, sum of the probability should be 1. So if I sum over all the states, summation over j, because this is fixed. So by the definition, sum should be 1.
Yes, sir. Got it. Got it.
By the definition itself, because sum of the probability should be 1. Also, you are fixing the conditional one. That's why. Also, it is talking about the one step only. Pij 1. That is the Y condition. One we have written. Okay, so now let us take another example. Okay, so let xn n is 0, 1, 2 be a sequence of IID discrete random variable with probability x1 is equal to j, which is half raised to power j plus 1 for all j, which is 0, 1, 2 and so on. Determine whether each of the following chain is Markovian or not. If so, find its corresponding states space S and TPM. First is Sn, n is 0, 1, 2 and so on, where Sn is summation xi, I is from 1 to n. Second, Mn, n is 0, 1, 2 and so on, where Mn is maximum of x1, x2, xn. So solution is, so we have to, because they are IID, independently identically distributed random variable, so their x1 and x2 have same CDFs and probabilities, etc. Okay, x1, x2 and so on. So they are IID and independent also. Now Sn is summation xi, I is from 1 to n, and the values taken by xi is 0, 1, 2, 3 and so on. So Sn is a discrete time Markov chain with state space 0, 1, 2, 3 and so on, because x1, x2, x3, all of them can take value 0, 1, 2, 3. So their summation will also take the value 0, 1, 2, 3 and so on. So that will be state space. Also, if Sn plus 1, the value of this depends on value of Sn, because this will be Sn plus Xn plus 1, not on how we have reached this Sn. Okay, so therefore it will forget the past. So therefore Sn is basically a discrete time Markov chain by the definition itself, because it will forget the past basically, and just future depends on the present. Future will depend on the present, not on the past values. So therefore that is a basically discrete time, Sn is a discrete time Markov chain. Now we want to find the TPM. So if initial state I, final state j, I can take value 0, 1, 2, 3 and so on. Similarly 0, 2, 3 and so on. Okay, so now now where Pij is basically probability xn plus 1 is equal to j given xn is equal to I. Okay, so P00, that means P00 means here instead of Sx we have S basically S. Okay, so summation is 0. In the next step, summation will remain 0. Okay, so that will happen if the summing whatever the value we are summing, that take value 0. Okay, so we can denote that will be basically half from here. X1 is equal to 0 because they are IID, so that will be half. Okay, now summation is 0. In the next step, summation becomes 1. If x1 becomes 1, that means half raised to power 1 plus 1, that means half raised to power 2, that means 1 by 4. Okay, similarly, in value is 0, next step it becomes 2. If x1 becomes 2, that means half raised to power 3, so that means 1 by 8. Similarly, this becomes 1 by 16 and so on. And now the initial value is 1, final becomes 0. Because this is we are doing the summation and values taken are 0, 1, 2, 3 and so on. So therefore, the value becomes any value comes, value cannot become 0 in the next step. So that probability is 0. Now, if total is 1, next time value becomes 1. Okay, after one summation of one value, but that can occur if 0 comes. Okay, that means with probability half. Similarly, 1 to 2, if initial is I is 1, this becomes 2. If basically 1 comes, 1 by 4, 1 by 8 and so on. Similarly, this will be 0, 0, 1 by 2, 1 by 4 and so on. This becomes 0, 0, 0,
Sir?
1 by 2 and so on. Yes.
So could you please explain that 0 part again? Why it is coming 0?
In which this first one or second?
So
first,
I equal to 1, j equal to 0, that one.
Okay. So x1, x2, so on, they can take value 0, 1, 2, 3, so on, because this is the state space. Now, Sn is 1. Sn plus 1 is Sn plus some xi, xn plus 1. Xn plus 1 are IIDs. So this can, because this is 1, whether this take value 0, 1, 2, 3 and so on, total summation cannot be 0. Okay, so
Okay.
therefore this is an impossible event. So probability of that will be 0.
So from where did we get this equation? Sn plus 1 equal to Sn plus xn plus 1? Or is it given to us?
This is already given, na? This is question itself. Sn is this. We have to show that whether it is a Markovian or not, whether it is a Markov chain or not.
Okay, sir, got it.
First of all, I have shown that this is a discrete time Markov chain. Then we have calculated the transition probability matrix.
Yes.
Now, in the same fashion, you can do the second part also. And let me give you the answer. So for the second part, answer will be state space is 0, 1, 2, 3, and so on. And TPM is 0. Okay. Although no need to write this also. 0, 1, 2, 3 also. 1 by 2, 1 by 4, 1 by 8, 1 by 16, 0, 3 by 4, 1 by 8, 1 by 16, 0, 0, 7 by 8, 1 by 16, and so on. Okay, so that is the answer. In the same fashion as we have done previous one, in the same fashion for maximum we will do. Okay, so till now we have done some examples where we have shown that whatever the stochastic process is given, that is discrete time Markov chain, and find it out its TPM. But sometimes we have to basically make the Markov chain. That is basically sometimes directly we cannot find, but some other fashion we have to make that. So let us take an example, transformation of a Markov chain. Of a process into Markov chain. So suppose that whether or not it rains today depends on previous weather conditions through the last 2 days. Suppose that if it has rained for the past 2 days, then it will rain tomorrow. It will rain tomorrow with probability 0.7. If it has rained today but not yesterday, then it will rain tomorrow with probability 0.5. If it has rained yesterday, but not today, then it will rain tomorrow with probability 0.4. If it has not rained in the past 2 days, then it will rain tomorrow with probability 0.2. Okay, so let us define yn as the state. Let us say that weather condition on nth day, weather condition on that day basically. So from the question, because we have to make the Markov chain using the question. So it is saying that weather condition depends on last 2 days. Okay, so yn will depend on yn minus 1 and yn minus 2. Okay, but other value it may forget. But that is not the definition of discrete time Markov chain. It should depends on the previous only. Okay, so therefore it is not a Markov chain, discrete time Markov chain. So how we can make it a Markov chain? Because it depends on the question. The question, whatever asked here, doesn't make this yn as discrete time Markov chain. So yn is not a discrete time Markov chain. So let us define xn as the state at any time is determined by the weather condition during both that day and the previous day. So now xn depends on that day and previous day. So therefore the xn plus 1 will depend on that day and tomorrow and today. Given xn, xn will depend on today and the yesterday. So weather condition on that day depends on basically 2 days now. Last 2 days, weather condition of last 2 days. So therefore, it will not depend on these. So therefore, now xn becomes a discrete time Markov chain. So in this fashion, we can make, depending on the question, we can make the transformation of the process into a Markov chain. So let us say we want to find what is the state space and what is the TPM of this xn. Okay, so let us denote that. Let us say that state of xn we are denoting as 0, 1, 2, and 3. If it rained yesterday and rained today. So if it rain yesterday and today, that is state 0. If it does not rain yesterday but rain today, that is state 1. If it is rained yesterday but not today, that is state 3. If doesn't rain yesterday and today, that is state 3. Okay, so that is the our notation for that state, because we can make our notation for the states. Now, what is the TPM for xn? So states are 0, 1, 2, 3. Final is also 0, 1, 2, 3. 0 means yesterday raining, today raining. Okay, and xn plus 1, because Pij will be probability xn plus 1 is equal to j, given xn is equal to I. Ij belongs to state space, which is 0, 1, 2, 3. Okay. So this is today and this is tomorrow. Now clearly this TPM contains these conditional values. Now it is saying that it is, I want to find, let us say, this value P01. Okay, P01 I want to find. So it is saying that probability of it is raining tomorrow, this value, not raining today, given that it is raining today but and raining yesterday. But that is not possible, because one way it is today is not raining and today it is raining, so that is basically 0. In the same fashion, this value is also 0. In the same fashion, you can see this and this value, that is 0, and this value is 0. In the same fashion, you can say this and this should be same, but they are different. So therefore, this is 0. In the same fashion, this is 0. This is 0. This is 0. Is it clear how this is coming to be 0?
Yes, sir.
Okay, okay. Now the other values. The other values, it is given in the question. What is the probability that tomorrow it is raining, today is raining, given that today it is raining, yesterday it is raining. So it is given in the question. So suppose that if it rained for past 2 days, then it will rain tomorrow with probability 0.7. So this is given to be as 0.7. But we know that sum in a row is 1, so therefore this is 0.3. In the same fashion, if it is raining tomorrow, find out this value. Today and yesterday it is not raining. If it has rained for 2 days but not yesterday, then it will rain tomorrow with probability 0.5. If it has rained today but not yesterday, but rain tomorrow with probability 0.5, that is 0.5. Similarly, this is 0. Because sum in a row should be 1, so therefore this is 0.5. In the same fashion, this value is also given 0.4, 0.6, and this is 0.2 and 0.8. So any question in this one? This is the TPM, transition probability matrix.
So no, sir, no questions.
Okay. Okay, so I think I stop here today. So today we have basically started with a discrete time Markov chain and see how we can basically make the discrete time Markov chain for different questions and how to check and how to make the TPM and state space, how to make that, and some transformation of the process into Markov chain also we have done.
Sir, could you go back to the previous question?
Okay, just wait. I think my screen is now, I think, visible.
Yes, sir.
Somewhere to protest against this lockdown.
Sir, can you explain how you got P from, or is?
Okay, okay. This question. Okay.
Sir, I just wanted to note down the answer for this.
Because this Sn is basically sum, and this state space for that is 0, 1, 2, 3, so on, because xi can take values 0, 1, 2, 3, so on. So summation of them can also take value 0, 1, 2, 3, and so on. It is clear because summation x1 plus x2 can take value 0 or 1 or 2 or 3 or so on. So therefore, state space is this. Now, Pij, Sn is discrete time Markov chain. It is also clear because the future Sn plus 1 depends on Sn, not on the Sn minus 1, how we have reached Sn. So therefore, that is a discrete time Markov chain. Now we have to find TPM. For TPM, we have to write down this value, Pij. So let us say Pij is, I want to find P00. Probability that Sn plus 1 is 0, given Sn is 0. Okay, so summation is 0 in the next step, because this is summation xi. Okay, summation xi is 0 and Sn plus 1 will be Sn plus xn plus 1. So xn plus 1 are IID, independently identical. That means x1 have same distribution as x2, x2 has same distribution as x3, and so on. So therefore, how, if Sn is 0, how this summation can be 0? This summation can be 0 when xn plus 1 take value 0. That means that is same as x1 take value 0. And what is the probability of that? Probability of that is half raised to power 0 plus 1. So that means half. So that is answer is half. Now, if we want to find P 0, 1. Now summation is 1. The next step summation is 0. Next step summation is 1. Okay. So that is only possible if this xn plus 1 becomes 1. So xn plus 1 becomes 1. What is the probability of that? Half into 1 plus 1. That means 1 by 4. Is it okay? Or some
Yes,
other?
understood. Thank you.
Sir,
Hello, sir.
Yes.
hello.
Sir, sir, I am a question, sir. Sir, in this question, if the probability of P of xi is equal to half raised to power in place of half, if it would have been 1 by 3, sir, then it would be having.
But that should also depend on this summation should also be 1. Total summation of this row.
Yes, sir. If it would not be possible, sir, then it will be not. It will not be a discrete time Markov chain, sir.
If that summation of the row is not 1, then that is not a discrete time Markov chain.
Sir, but we have decided that this is a discrete time Markov chain before drawing the TPM, sir.
But
Actually,
that condition should be satisfied, na? These conditions should be satisfied that Pij should be between 0 to 1 and between 0 to 1 and this summation of the row
yes, sir.
sum and all the row sums should be 1.
Yes, sir. Then we can decide that this is a discrete time Markov chain only after drawing the TPM, sir. Calculating.
No. Before that I have decided, na?
Yes, sir. But here we are not considering the what is the probability of P of xi, sir.
No. But that should be satisfied also.
Sir,
If
sir,
that
I have a doubt, sir. Actually, sir, in this question, we have decided that this is a discrete time Markov chain before calculating the TPM, sir. And in this,
no. But yeah. That is all right. But if that is not the case, then you cannot say if that is not happening. But you can, if that is all the condition not satisfied, then how you can say? That's why we are making the TPM, because if that condition is satisfied, that condition should be satisfied. Na? Then only.
okay, sir.
All the conditions should be satisfied.
Okay, sir. Thank you, sir.
Sir, can you explain that or rain yesterday and today TPM once again?
Okay, just wait. Okay, my screen is visible.
Yes, sir. So
This
here
transformation of Markov chain.
yes, sir. Transformation. The matrix part.
Yes.
So here
So-
for J, we, just small for I we are taking it to be rained yesterday and rain today, and for J instead of yesterday we take today and instead of today we take tomorrow. That's it. That part
Yes,
is
because we have to make this, whatever question is given, we have to make that in a discrete time Markov chain. For example, I have in some other question, let us say in some question where it only depends on the previous day and depend on n minus 1 only. Then this y1, yn have done that this is a discrete time Markov chain. But in this question, this is different because it depends on the weather condition of last 2 days. So to take care of that, we have to make the states in this fashion such that it remains a discrete time Markov chain. Because if we make this yn weather condition on that day, the weather condition will depend on last 2 days. So therefore, by the definition of the discrete time Markov, that is not a Markov chain. But if we make state at time is determined by weather condition during both that day and the previous day, then this will depend on today, tomorrow, because xn plus 1 is today and yesterday. So xn plus 1 will be tomorrow and today. Okay. Now, what are the states? States will be weather, because this is weather condition of today and yesterday. Weather condition, maybe it is raining on both days, yesterday and today. It may be one which is rained yesterday and rained today, doesn't rain yesterday and rained today, and 2 and 3. After that, it becomes a, because xn plus 1 depend on tomorrow and today, xn is depend on today and yesterday, and this will depend on yesterday and before that day. But that will, because xn plus 1 depend on the 2 days only. So therefore, this will depend on xn only, not on xn minus 1. So therefore, it will make a discrete time Markov chain if the conditions are satisfied. Okay, so this will make a discrete time Markov chain. Now, other probabilities, the probabilities are okay.
The probability, so just explain the 0, 0, 1.
Yeah. So this one is in the xn plus 1 is equal to j. And this is xn is equal to I. So xn plus 1 is equal to 1 means it is doesn't rain today, but rained tomorrow. Okay. So therefore, but you can see here the difference. Probability of this, we have to find P01. We have to find P01. So now it is doesn't rained today, rained tomorrow, given that it rained today, but rained yesterday also. But it is clear that this is not same here. Today condition are different. So that is an impossible event. Okay, so therefore probability of that will be 0.
Yes, sir, got it. Thanks, sir. Yeah, understood.
Okay, so I'm stopping here.